Hi everybody, this is the grade 10 theory lesson, unit 10A, and today's topic is interval inversion. So our previous lesson we learned about some different intervals that we hadn't encountered before. Those were the diminished, the minor, and the augmented intervals, and we still maintain the major and perfect intervals. And in this lesson we're going to learn about basically flipping these intervals upside down or rearranging them. So that's what we mean by when we say inverting an interval. This can easily be accomplished with an octave displacement of either pitch. So there's two ways to do this. You can either take the top pitch and lower it by an octave, or you can raise the bottom pitch by an octave. And by doing that, in either of those cases, you will create a inverted interval. So once we've inverted the interval, we need to rename the interval because obviously it's no longer the same. So if you know the name of the original interval, you can find its inversion by using the following information. The first one is that the number of an interval plus its inversion will always equal the number 9. So firsts become eighths, and vice versa. Twos become sevenths, and vice versa. Thirds become sixths, and vice versa. And fourths become fifths, and vice versa. So this does not matter if we're talking perfect, diminished, major, minor, augmented. As long as the numbers will always equal 9 in any of those cases. The second piece of information is the relationship that exists between different types of intervals. So major intervals will become minor intervals when they are inverted, and vice versa. And the same goes for augmented and diminished intervals when we invert those. The only ones that do not change are perfect intervals. And if you think about it, our perfect intervals 1, 4, 5, and 8. And if you look at, just glance up at number 1 again, we know in all of those cases those are perfect intervals. Those numbers will always equal 9. And we have, if it's a perfect fourth, yes, it'll be a perfect fifth. There won't be any change that way. So those are the only ones that don't actually change when we invert them, and that's referring to the quality. So a few examples. A perfect reversed inverted. You can see what that looks like. So a low E and perfect unison might be another name for this one. And when we invert it, we have two pitches. We'll take either of those pitches, we'll raise it the octave, and we would create a perfect eighth. We could also take either of those pitches and lower it by an octave if we wanted to use some legend lines, and we would get the exact same answer. A major second that looks, this is what it looks like when it's inverted. So in this example, the note on the bottom, the G, was raised by an octave. The A maintained. So this is another critical piece of information, is that you're only moving one note. And if you are deciding on moving, so just to use this as a quick example, the note that is on top will come down the octave. The note that is on the bottom will go up the octave. We never want to be raising the note that is above the lower pitch and raising it by an octave. That actually will create a completely different interval. We'll start getting some compound intervals, for example. And we're not doing that quite yet. So very important, the bottom note goes up or the top note goes down, but do not lower the bottom or raise the top an octave. Okay, there has to be that flipped, inverted step needs to take place. Minor third that it gets inverted. Okay, so the A flat was, or the C flat in this case, was left where it is, and the A flat was raised an octave. And an augmented interval, the F double sharp was lowered by an octave to create the diminished fifth. So we're still, the first part of inverting of intervals is still always going to be identifying what we have originally, still treating it like a regular interval, still treating it as we are trying to find a benchmark, and then determining what's taken place from there. So once you've done all of that, the rest of it's quite simple actually. It's basically just going, one of the pitches is going to stay where it is, and the top's going to come down. Draw that, or the bottom goes up. You can do either of those. You're both scenarios will be fine. And make sure that you have numbers equaling the number 9, and if it's augmented, it's going to become diminished. Perfect stays perfect, minor becomes major. It's really not that challenging. It's actually quite simple once you've established what the actual interval is, which, again, we have lots of practice doing from other lessons. A couple more examples here. Here's some diminished intervals and what they look like when they're inverted. So in this case, the lower note was raised up the octave. Okay, diminished fifth becomes augmented fourth. The A, in this case, stayed where it is, and we brought the F flat down by an octave to create that augmented third. And then a few more, some augmented intervals becoming diminished intervals, and you can see how these ones are working as well. So again, once you determine what the original interval is, and remember that augmented becomes diminished and vice versa, those relationships, the rest is quite simple. Just, again, one of the notes will stay where it is, and you'll just decide to move whichever one you want. So that's the first part of inverting in intervals. But we haven't, and another scenario that you might encounter is you might be asked to draw an interval that's below a given pitch. And this is something that we can still determine, and we're still going to be using previous lessons and steps and methodology to determine how to do this. So when you are asked to write an interval below a given pitch, it's can be potentially quite challenging to imagine the inversion and without any kind of reference point, because again, we've always been solving intervals for a given pitch and above. So we're going to maintain that method of determining what's taking place. We'll just have a couple extra steps to do that, but that way we're still practicing the same procedure. So when we are asked to write an interval below a given pitch, it is easier to write the inversion above the given pitch and then drop the octave. So to do this, we're going to do the steps below. So step one is figure out the inversion of the given interval. So we're asked in this question to write a perfect fifth below a B flat. So right away, we're going to ignore a perfect fifth below, and we're going to think, what's the inversion of that? And going back to the chart we had earlier, perfect intervals maintain their perfect relationship. The numbers need to equal 9. So another way of thinking of this question, instead of a perfect fifth below a B flat, what's a perfect fourth above a B flat? And that's actually what we're going to do in this case. So we determine that that's an E flat. So B flat and E flat, that's a perfect fourth. It does match, it's diatonic to the key of B flat. There's no need to change any accidentals. And then what we're going to do, once we've determined what the note is above, then we bring that note down a full octave, and that will create the original question that we're asked to solve. So a perfect fifth below a B flat, again, think the inversion, perfect fourth above a B flat, that's an E flat. Once you've got the pitch and you know what it is above the note, remember you still need to bring it down the octave, so it's going to go down here. Another example, write a major seventh below. In this case, we're in the bass clef, we have an F sharp. An easier, again, way to think of it, major 7 below, right away think the inversion. Minor second above. What's a minor second above an F sharp? In other words, what is a minor second above an F sharp? So a major second above an F sharp is a G sharp. Remember, F sharp major, 6 sharps. And again, we're always solving interval questions using the major key signatures as the benchmarks, and then determining what the alteration is that's taken place. So an F sharp to a G sharp is a major second, an F sharp to a G natural would be a minor second, and then the last step is to bring that G down a full octave. So a G to an F sharp is a major seventh. And that's actually another thing you can be doing with your intervals, and once you've inverted them. So if you're ever unsure if you've done the correct steps, you can always check your work. So once you've determined what the final answer is, treat it as the original question said. Instead of below, think of above. So what's a perfect fifth below a B flat? Well, once you've determined what that is, what's a perfect fifth above an E flat? And your answer should be B flat. So you can always be double checking your work. Same goes for here. Major seventh below an F sharp. You determine it was a G. Well, what's the major seventh above a G? And it should be an F sharp. So you can double check your work in these cases as well. All right, the cover-up method, everybody's favorite. If we could only do this in real life sometimes, right? Just ignore a difficult scenario. So this method will work, just like we did in 6B when we did our different types of intervals. So we've got, in this case, a D sharp in the bass clef, and we are asked to write an augmented sixth below a D sharp. Well, we know there is no such key signature as D sharp major. Yes, there is a D sharp minor key signature, but again, we're going to be solving all of our intervals. We always want to be maintaining using the major scale as the foundation for solving intervals. That way we're practicing the consistent methodology that way. So let's ignore it that it says a D sharp. Let's just imagine it's a D natural. Okay, so what is an augmented sixth below a D? Well, what's the inversion of that? It would be a diminished third above a D. So the note D, the diminished third above a D. I'm actually not quite sure why this question is, that's actually an error there. But anyways, a diminished third above a D to an F sharp is a major third, a D to an F natural is a minor third, and a D to an F flat would be a diminished third. So this one would need to be the F flat. Bring that one down the full octave, and then remember, incorporate the D sharp, so that F flat would actually just become an F. So an F to a D sharp would be augmented sixth. Okay. And a couple more examples here. So this question, there it is. There's the final answer. So a couple more steps that are involved there, right? So D to F flat, diminished third. Add the D sharp back into the equation. Make sure you've dropped the interval so you're getting your augmented sixth, so an F to a D sharp again.